You're building a very interesting product for cows.
I was born in the Waikato and grew up basically on dairy farms. Farming is lifestyle more than a job that people go to and then come home from and forget about it. I could create a device which makes 1 million doctors 5% more efficient. We're basically trying to improve the diagnosis of septicemia, mastitis, which is the biggest disease in the industry. Terrible for your profits and your production, but also horrible for the cow. Uses a lot of antibiotics. Cows are very good at hiding any discomfort. We have 145 farms now with the product, so that's about 2% of the market that we've captured from no product to a year after launch.
This is Mark Popitkowski, and welcome to the TechMates podcast, where my partner Henrik and I explore how Kiwi and Aussie founders are reshaping the future and what sets them apart. Henrik and I have been part of successful companies in Silicon Valley and Europe, and now bring that expertise to partner with entrepreneurs in Australasia. By sharing the personal stories of successful Kiwi and Aussie founders and how they got here, we hope to inspire you to dream big. This is TechMates, bringing an outsider's perspective to the stories of those daring to disrupt down under. Let's dive in.
Cool. Liam, welcome to TechMates.
Thank you very much for having me. Looking forward to it.
You're building a very interesting product for cows, which is not something we see every day. So we're very interested to learn more about, your AgTech.
You're founder of Bovonic, and we're going to dive into the company a little bit later. But as always, we want to start with where you grew up. And as somebody who's working with cows, I'm sure you grew up in the countryside. Is that right?
Yeah, very, very good guess, and you're absolutely right. I was born in the Waikato and grew up basically on dairy farms. My parents are dairy farmers, so I grew up in the Waikato around Morrinsville and Te Aroha, and then moved over to the Bay of Plenty when I was younger, which is a lovely spot to grow up in the sun. And yeah, as you say, I really enjoyed the farming childhood, a lot of space and openness, and a chance to play and be creative. So yeah, really enjoyed that environment. And you don't actually realize all the little things you're picking up, even if you're not actually the farmer at 10 years old. You do from osmosis learn a lot about farming.
What kind of stuff did you learn?
Just that the weather is the constant topic of conversation. It's just always about the weather. Just that farming is lifestyle more than a job that people go to and then come home from and forget about. It's people's whole lives and passions, and all their conversation, all their talk is really about farming. And so I think it's a unique industry and life that people have.
What would you say characterizes that lifestyle? What does it mean to be a farmer?
Yeah. Well, I think as you just said, it's actually a lifestyle. It's not a job. And so I don't think there's another place where your job and your friends and your family are so intertwined all the time. Family does tend to run in families, and there's always that connection back to the land and things. So yeah, probably the all-encompassing nature of it. It's pretty hard to escape.
Would you say there's a certain kind of personality that is true of most farmers, and most farmers are certain?
I wouldn't say so. I think a lot of people are just born into it, and there are some people that enter it coming from town, but you don't meet a lot of them. But in terms of farmers themselves, there are all sorts. There's people that love being by themselves out in the middle of nowhere. There's some people that have really big social lives with other farmers or with whoever. So yeah, I'd say it's all sorts.
Did you want to be a farmer when you grew up?
No, I don't think so really. No, I think I was frustrated with the weather part of it. I was frustrated how uncontrolled that was, and maybe that was a bit of a foresight into my engineering future. I love that idea of being able to control the parameters and determine that outcome, whereas that is quite difficult to do in farming. You can be the greatest farmer, but if the weather doesn't go your way one year, it's going to be tough.
So you're frustrated with how unpredictable it is, and that you're always exposed to
I was
these
always into
external factors.
my science, my maths, and I think I like the predictability of it maybe.
To me, farming, it's always like, oh, well, you just put some crops out and you just wait for them to grow. But is there actually some kind of can you be a good versus bad farmer? What does that even mean?
Yeah, absolutely. Certainly in New Zealand, I don't want to say more than all other places, but a lot of places around the world, farmers get subsidies, and that supports a lot of their income. And so you can almost just be an okay farmer and get by. Whereas in New Zealand, the subsidies were cut. There is no support, and so you have to be a fairly good farmer if you're going to make any money and survive and not lose your farm. So certainly, yeah, there's a huge amount of skill in it, and it's a bit of everything. You have to understand soils and pastures and animal health and the mechanics of a milking machine, and how to optimize for vacuum and flow rates and feed budgets and nutrition. And so there's a huge amount of knowledge in it. And then just general management. You got to be a manager of staff. Yeah.
Sounds like a good training ground for entrepreneurs.
Yeah, exactly. It's not about you've got your one job to do and you go do that one job every day. You've got to be a business owner, a manager of people. Yeah, be able to take some fairly unpredictable things coming your way and just roll with it.
What's the history? Why were subsidies cut in New Zealand?
Yeah, it was interesting. It was actually a Labour government, but they decided to deregulate, similar to the Conservatives in the UK. I'm not an expert at this at all, but I think that's my understanding. They just decided that, more free market economics was going to make everything more efficient. And certainly for farming, that is what happened. New Zealand farmers became the most efficient in the world fairly quickly. We've had a bit of a plateau in productivity, in the last 15, 20 years, but from the 80s to the 2000s, we just had a lot of the great innovations and a lot of the great productivity increases because we had to, or else would collapse. And so, you can have a farm in Ireland with 50 cows and you can support a family and the grandparents as well. Whereas here, you really need at least a couple hundred cows.
And did your parents, a lot of farmers want their kids to kind of take over, right? Did your parents ever put that on you?
My parents were share milkers, so we didn't actually own our own farm. So yeah, there wasn't that pressure to take over, which a lot of farming kids have. Yeah.
Okay.
And my parents always really encouraged me, farming is great, but if you do work hard and work smart, you can have whatever future you want. I was always very interested in being an inventor for some reason from a very early age, absorbing as many non-fiction encyclopedia books I could get my hands on. Loved, Da Vinci and Edison and all of this. So for whatever reason, I was really obsessed with this idea of creating new things from quite an early age. But in saying that, I'd have these books of ideas and notebooks of ideas, but I never actually knew how to implement them or what to do about it. So I'd love to have had a child invention that I made, but I never actually made anything as a kid.
So the obvious choice for you was to go and study engineering then, to kind of be able to make this ideas reality.
Yeah, I had the chance just before the final year of secondary school to go on a science camp, as nerdy as that sounds, but it was a great time. And we got to stay at Auckland University for 2 weeks, and they basically showed us every kind of engineering that you can take there, each discipline. And then they had a program where you could skip the first year of engineering if you had good enough grades and just go into that discipline immediately rather than doing that first general year. And yeah, I got to see all the parts of biomedical engineering, and I said, this looks like the most cutting edge, the most innovative form of engineering at the moment. And so I just dove straight into it and skipped that first year. Yeah, the idea of bionic arms and 3D printing organs and curing diseases. And yeah, it was pretty exciting.
Was this in Mass?
This was Auckland Uni.
Oh, okay.
Yeah. And I had thought about, I guess when you're doing okay at school as a kid, people say, well, why not go be a doctor? And something I thought about, but I also thought if I could create a device which makes 1 million doctors 5% more efficient or 5% more successful, that's even better, isn't it?
Yeah, that's cool. I think Auckland has one of the best biomedical departments in the world, right?
Yeah. The institute up there does a lot of good work. So that was, I guess, when I was 18, decided to go for that, and so spent 3 years getting that engineering degree. Met a lot of good people, had a great time at uni, and pushed through it fairly quick.
Did you want
to get out there?
Did you know that you want to do like a company later, or what was your plan, I guess, in university?
Yeah, it's interesting. I always wanted to be that inventor, but an inventor isn't the same thing as actually bringing that into the world. It's just kind of having that idea or making a concept. And so I didn't really know it at that time. So when I finished uni, I didn't know whether I wanted to go into industry or maybe it was academia was right for me. And so I did do a summer research internship in Australia for that summer after uni. And to be honest, I quickly realized it wasn't for me. I really wanted a team environment of everyone focused on the same thing. And I found that everyone was quite obsessed with their own publishing schedules or what they wanted to do. And there was that disconnect from how long is it actually going to take for this to get to a real person, what we're doing here? And so maybe I'm just impatient. But after that summer of doing that, I was like, no, I've got to be in industry. Business is the best vehicle for taking ideas and getting that to people.
Right. And then you first took an industry job, right? Back in New Zealand, or was that in overseas?
Yeah, the interesting thing about biomedical is that it's so advanced and such an innovative degree. There's not a huge number of jobs in New Zealand for it. Fisher and Paykel is probably the standout or at the time was the standout example of that. And yeah, I was looking for something different. So I went straight over to London after that summer internship in Australia. And yeah, really found my dream job very quickly. I still feel very lucky to have got it. But it was basically as a graduate engineer at a company called DNA Electronics. And this was a fairly large startup, about 100 people split between San Diego and London. And we're basically trying to improve the diagnosis of septicemia. And so septicemia kills about 50,000 people each year in the UK, basically because it takes a few days to diagnose it before you can give the right antibiotics. If you're able to diagnose it within hours, that would totally change the game. And that's what we were trying to do there. So this was a device where a nurse, not a lab technician, could put in a blood sample. It would extract the bacteria that was causing the septicemia, sequence the DNA, and then within a few hours, we'll be able to say, it's this bug with these mutations, give this exact antibiotic, and you should be able to cure them.
Interesting.
So yeah, a great big team to be involved with, very substantial funding. And so it's a great learning environment for a graduate from little old New Zealand.
And it's sort of like very, very similar to what you would eventually end up doing for cows, right?
Yeah, well, yeah, I guess by design, I would say. Yeah, so I did that job for 4 years. And then
What'd you learn? What were the biggest learnings? Like, I mean, both from like that point of view of like engineering and just how engineering actually works in real life, and also from the point of view of like just getting products to market and like interfacing with patients.
Yeah. So on that first point, I quickly realized that university is quite a good broad understanding, but it's just nothing compared to even the first 2 months on the job. So yeah, I learned a huge amount of practical skills. And because although it was a big team, the engineering team was quite small. So even though I was a graduate, I got thrown into quite a, like I was coding and I was designing flow cells, and I was doing a lot of the biological side as well, and designs of experiments for testing all different parameters for basically improving sequencing. So I got to see this really broad array of things and learned a lot of skills that way. I would say in terms of commercialization, I think I learned quite a few things of what not to do sometimes. And maybe it was because we did have a lot of funding. It was, yeah, I just saw the power of project management basically. And I got to do a little bit of that towards the end of my time there. But yeah, how do you capture knowledge so things aren't just repeated over and over as new staff come on? And when you do a test, what does it actually mean? And how do you interlace that with everything else that everyone else is doing? So yeah, I really saw the importance of organization and systems and processes around project management.
Interesting. Do you think, I mean, to your first...
Yeah, so they still haven't actually released that product.
Really?
It's a huge, complicated thing they're doing. But yeah, I endeavored, if I was going to do it myself, to try to streamline what we could.
To your first point of like, you learned a lot more, or almost the same as in 2 months of like working in industries, got in your like 3-year degree or whatever, 4-year degree. Like, do you think there's like, in the age that we live in today, there's any point to students going and getting degrees? Like, it just seems like such a inefficient use of time.
Yeah, I do often say that, and maybe I'm not seeing what it did for me. I think people often use degrees just as a thing like, okay, you can stick to something for 3 or 4 years and that proves something about you, maybe. That seems to be, but I mean, at Bovonic, we hire people with and without degrees, and everyone just gets stuck in, and it doesn't seem to correlate highly with what people end up doing or how good they're at it. Yeah, certainly 3 or 4 or 5 years seems like a long time of your kind of most energetic, creative years to be spent just listening.
It feels like you kind of wasted it a little bit, right?
Yeah, maybe 1 year. So at least you get out of home and live by yourself and live for yourself, and still learn from people and learn some good self-management practices.
I guess the other reason why like degrees are probably useful is to have like some sort of certification from a third party that says like, this guy knows something in whatever, biomedical or whatever. If you don't look at, like, if you hire outside of degrees, like how do you, like at Bovonic, how do you do that? Like, how do you make sure people know what they need to know?
Yeah, to be fair, we've not hired graduates without degrees, in the sense that people have always had other jobs for the roles we've hired there. And so their experience and what they've done in their other roles has been sufficient, and just your gut feel of that person. I mean, if they're a positive person who's hardworking, that's pretty amazing what people can do once you just set them onto something.
Yeah, they can probably figure it out.
You are right. You know, people need some, especially in larger companies, you need some fallback to say, look, I tried to make the right decision, and maybe a degree gives employers that, or the employing person that.
Yeah, it's just like an extra cost falling on you as an employer, right? To kind of check for those skills. Whereas like if you hire somebody with a degree, you can, like, the probability that they know something about the
Yeah,
space that you're hiring for is probably higher.
But
yeah,
I would
probably.
argue that's not necessarily true, right? Like it's what Liam was saying. Like the stuff that he learned during the degree wasn't super useful to the job. And what was probably more indicative of his success was his ability to learn quickly, and he didn't really get the degree didn't really validate that, right? So if that's the useful skill to have, and the degree doesn't validate it, like yeah, the employer still needs to like suss out if you have that skill or not.
Yeah,
I
it's
don't know if
just an
it really should
assessment, right?
be a bigger mix of work placements and less just learning. And because then you could turn up at a job as a graduate and say, not only do I know these things, but here's 2 people that I've worked for who can vouch for me, which is what most graduates are missing. And it's really the biggest unknown.
Fair enough. Just on that, I guess you're not the only Kiwi who went to London after their degree. Like, I feel like a very common thing, right? What was that experience like for you? Like, what did you learn living overseas, and why did you end up coming back?
I think I had quite that farm childhood was very good, but I feel like I always had quite a sheltered, easy childhood in a way. And so I think I was really looking forward to proving myself as an independent person. And so maybe that's why Kiwis do it. But I was like, okay, let's go to the other side of the world. Obviously, London's a lot easier than going somewhere non-English speaking or a bit of a tougher place. But at least you're living on the other side of the world by yourself. You have to sort it all out without any help. So part of it was just going there and proving to myself that I could go and do that, like that I wasn't actually an adult. So yeah, London, I still love London. New Zealand is great, certainly for some peace and quiet and the nature and all of this, but just 8 million people stuck in one spot, that energy, and it's just hard to replicate elsewhere. And I'm sure all big cities are like that, but I kind of immediately felt at home in London, but I had all of this energy and opportunity as well. So yeah, learned a lot about myself, became an independent person, and had a whole lot of fun.
Okay.
And
And
yeah, it was
what
all
triggered
good.
the decision to come back?
Yeah, so my girlfriend, or my now wife, she was a travel agent at the time at the start of 2019, and that wasn't a great time to be a travel agent. We were going to find out. Yeah, COVID happened. The company I was working for were actually in the transition of moving from one site to another, and that kind of totally fell apart through COVID because the new building couldn't get finished, but we had to get out of the old one. And so we ended up in these temporary working spaces. 90% of the team was at home, unable to do any of the lab work. That kind of all slowed down. My girlfriend lost her job as a travel agent. And we're also in this tiny flat, no balcony, no garden, just locked in there. And then there was this idea of coming back to New Zealand with a farm, kind of endless green pastures. So that seemed really quite appealing at that time. And so we just made the call.
Did you guys manage to come back during COVID? Because it's pretty hard to get into New Zealand, especially if she's not a New Zealand citizen or resident.
Yeah. Yeah, luckily her dad's Australian, so she's got an Australian passport too. We quit our jobs, left our flat in London, stayed with her parents in Scotland, and we probably booked our flights 5 or 6 times. Each time they'd get cancelled the day of the flight. And then eventually we got one probably after, was it 4 or 5 weeks?
Wait, so you'd show up to the airport and then they would just cancel it?
Yeah, the airport was only a 15-minute drive away, but it'd be cancelled kind of the morning of.
Jesus.
And then you would get your money back fairly quickly, if I remember right. But then you'd have to, sometimes you wouldn't, and like you'd be spending the next lot of money to get the next flight.
What a scam.
It was, and it was a great flight though, because there was only about 50 of us on an A380. So each person had about 4 rows each.
That's pretty good.
And we got in during COVID. So yeah, September 2020, we did the 2 weeks isolation in the hotels, and then come out, and it was a totally different world. There was no COVID loose in New Zealand, just endless space, going back to having a car to drive around in. It's a very different life all of a sudden.
Yeah, and London was miserable in that time, I remember. It's kind of going back and forth, but it was absolutely horrible. Even just to travel anywhere was a nightmare.
Yeah, it's kind of all the negatives of London and none of the positives.
That's right.
Yeah.
And then, so you got back to New Zealand, and what did you think you were going to do? Like, did you already think about Bovonic, or what was the time like?
Working in the startup, I had seen things that I liked and some things I'd like to do differently. And I thought I had that understanding, or was beginning to have that understanding. So I thought I could do it. We had the more sensible idea of we were going to go to Australia after a couple of months and get a job in, I don't know, product development consultancy or something in Melbourne, I think was the idea. But while I was here, I was doing a bit of work on the farm with Dad. I didn't have a job. We were just going to take these 2 months to just see what happened. And we had no kids, no mortgage, no house, no obligations whatsoever. And the longer we were staying here, I started thinking, well, this is probably my chance. If I lock myself into another job and then do that for 5 years, then it's going to be a very different stage of life. And so I should probably go for it now and do this dream of mine. And so it's feeling methodical.
And you always thought that you'd want to do a startup?
Yeah. Yeah. So I always wanted to be an inventor. And I think through all the experience in London showed me that, it's all good to be an inventor, but you actually have to make it real and turn it into something that people can buy and people can access and actually adds value and isn't there just for the scientific novelty. It actually has to be useful. And I think the farming background helped with that too. The farmers are fairly, they don't have a lot of time for gimmicks. It's got to be real and it's got to be robust and it's got to work straight away or they've got no time for it. And so that was my background growing up. And so I think that combined with this new engineering knowledge I had, I thought I could do it. Yeah.
And did you already had this idea in mind, or how did the concept come up?
Yeah, it was really from working with Dad on the farm. So he obviously milks cows. So this involves obviously getting the cows in from the paddock each day. They go into the cowshed, which is a row of milking cups, and you put the milking cups on the cow and it milks the milk out. And one of the big challenges in dairy farming is, the main disease is mastitis, and this is where the udder gets infected. And not only is this bad for profits and production, but it's obviously very painful for the cow. She can get very sick. Yep. So that's a herringbone milking shed, which was invented in New Zealand and is now very common around the world. And so you get the rows of cows in, and then you go down the row and put each set of cups on, and each cow milks for about 5 minutes. And so this disease, mastitis, which is the biggest disease in the industry, terrible for your profits and your production, but also horrible for the cow, uses a lot of antibiotics. And you actually get graded on it every single day by the milk processor. So each day you'll get a number of how you're doing with this disease. And if it goes too high, they won't pick up your milk anymore. So there's
how do they measure it? Do they test the milk every day?
Yeah, every day. So there's 11,000 farms in New Zealand. Every single day or every second day, a sample from every farm gets tested for a whole bunch of things: fat, protein, all different kind of hygiene tests. And one of them is called somatic cell count. And so this is a measure of the number of immune cells that's in the milk. And so if there's an infection in the cow's udder, the immune system reacts to that, and the number of immune cells in the milk increases massively. And so I believe they just run it through a cell counter. But it's a massive operation. Yeah, 11,000 samples to process every 2 days. And then the farmers get that number back.
If they hit like a certain level, or they're above that level, they're not allowed to sell that milk?
Yeah, you get a few. You're allowed to do it a few times, but if it keeps going, they'll just stop picking up your milk until you resolve the issue. And that all came from some standards that the EU introduced, I think in the 90s. And it's really a proxy for animal health. If you're not treating your animals well and they're unhygienic or have low immune systems, you're going to have high mastitis. So the EU said we won't import any milk from cell counts over a certain level because it suggests you're not treating your cows well.
And is New Zealand's main export market the EU? I thought it was China.
Yeah, the whole world just decided to accept that measure after the EU did. So I know countries like Brazil can't export a lot of their milk because they're well over that limit. And actually, if they could maybe be under it, there's a lot of potential there.
And so how do they currently, like if they, let's say a farm is above a certain level a few times, how does the farm address that at the moment?
Well, this is exactly what I saw my dad doing, which is the state of the art, which hasn't changed since cows started to be milked. You go to each cow and by hand you squirt some milk out of the teat, and you see if there's any clots or if it's watery or if there's some blood in it. And so this is okay if you've got 10 cows, but if you've got 500 or 1,000 cows, to manually go to each cow and squirt milk out of all 4 quarters can take hours and hours and hours. You're also potentially spreading the disease by handling every single cow. And you're only picking up quite late stage mastitis. You're missing all of the early stage mastitis.
So you're saying,
and so this is where the idea came from.
Your dad would be looking at it like visually? Can he visually inspect the milk?
Yeah, visually inspect the milk and visually inspect the cow to see, has the udder swelled up, or is there redness, or is the cow lethargic?
And would he do that preemptively, or would he do that only when his milk was being tested and the cell counts were really high?
Yeah, so Dad would tend to do it when they got high, which is his prerogative. But since then, they've actually introduced incentives for having low mastitis as well. So there's actually more financial incentive than there was even 10 years ago. But yeah, some certainly like organic farmers, some of them test every single day because they can't use antibiotics. So they have to get rid of those cows out at the earliest moment. So some of them have another person every day just checking cows for mastitis every day, well, twice
So
a day. For every
normally, if you detect mastitis, you would treat it with antibiotics and then
Yes.
it would get better. But in organic farms, you just kind of have to kill the cow.
Yeah, or you can give it some kind of natural anti-inflammatories and hope she recovers herself.
Okay.
Yeah.
Okay.
And so, yeah,
interesting.
this is exactly what I saw Dad doing, going up and down these rows of cows, searching by hand. I wasn't sure if this was Dad he's not big into technology, so I didn't know if this was just him. And so I started doing more research, and I realized this is what everyone does. There's 1 or 2% of farms in New Zealand that have some more automated systems, but on a day-to-day basis, this is what almost everyone does.
But presumably so women also get mastitis, right? Like if women are breastfeeding, and
Yes.
usually like you have like pain and there's symptoms. Like, is there no way to for the cow to express that it's in pain, or is there any other way to
Yeah, they're very stoic animal. I've heard it's because, in the wild, if they were more like buffalo, to show weakness or pain means you're the first target for that lion or that predator. And so cows are very good at hiding any discomfort.
How did you think about the solution then? Like you saw your dad kind of doing this manually and you're like, there's a better way.
Yeah, I was like, surely there must be some parameter of the milk that changes that we can measure. And so I did some research and found that it's all been solved already. Robotic milking systems exist where there is no farmer. The cow just walks herself to this robot and it milks the cow. And it actually, the big difference though, is that it milks each teat separately. Whereas all conventional milking systems, the 4 teats go into one collection bowl and it all gets merged together. And then it's very hard to pick out one of the teats which has the infection because it's only starts as one at a time, basically. The udder is actually 4 separate compartments. It's not one big bucket of milk. And so the infection starts in one, but all of that milk gets combined into one point, and then you kind of lose the signal from that infected quarter. And so the robots can do it. They just measure the saltiness of the milk, the conductivity of the milk. But because they can measure each quarter, they get a very accurate reading. Whereas all conventional milking cups at the moment, there are some milk meters that do measure the conductivity, but they measure it of the whole cow. And this is just not accurate enough because you lose all that signal it gets diluted out, basically.
so they get diluted out. I thought it was because you have a control in the 3 other teats.
Yeah, so for us, we compare the 4 teats to each other. And so you can assume that at least one of them is uninfected. And so we're looking for that delta between the infected one and the uninfected. Milk meters in the past have just measured the 4 combined.
Right.
So if you've got a 20% increase on one quarter, that's only a 5% increase once you combine them all. And cows could have naturally changing levels of conductivity. And so that 5% is totally lost in the noise.
How much variance is there between the teats if there is no infection?
It's about 25 to 30%.
Between the teats if there's no infection?
With no infection?
Yeah.
Yeah, good question. I don't know the answer to that.
But so it's like above a certain threshold.
It's quite stable.
Yeah. Yeah, it's like above like 20, 30%, then you start to get worried. Then you're like something is off.
That's that delta that we look for.
Okay.
We have a whole bunch of calibration features within our algorithm. So, but from what we see, they're quite stable. That calibration isn't having to do a lot of work.
Wait, Liam, how do cows get mastitis in the first place?
Yeah, so 2 ways. So it's either environmental. So this is where they sit in mud or crap or whatever, and it goes into the teats. And I think it's part of the domestication of the cow is that the teats become bigger and more open, especially after milking, because so much milk has been pumped out of them. And so for a little while after milking, those teats are more open and there's more chance for bugs to get into them. And then there's also contagious strains of mastitis, which are just spread on the skin of cows. So cows touching each other or in the milking equipment itself. Did
you not? Okay, so you have this problem. You can address it on a number of different levels, right? There's the cow having symptoms. There's maybe visually the teats change. Maybe there's a smell of infected milk versus non-infected milk. There's also you could maybe help disinfect the milking equipment, or you can try to close the teats after milking. There's a bunch of stacks along this whole journey of getting milked. How did you? Okay, so what was your thought process for thinking through how to address this problem?
Yeah, so prevention is obviously the best, and I guess all of those things require fairly either there's good solutions already and farmers aren't adopting them, or it's more larger scale changes to the whole farming operation where there's not really a business around that. I mean, you could be a farm consultant and go in and work with them and improve their systems, but that's not really what I was aiming for in a tech startup. So yeah, prevention's obviously key. And then the next step is us for the screening. And then after that is really the treatment. And so there's a whole bunch of innovations and interesting things in the treatment side as well. But I guess what I saw was the biggest gap was, farmers have options for treatment and prevention, but they didn't have any good option for the screening step. And so that's where I thought we should go in. And so I saw how the robots were doing it. So there was an established science, but the problem was we need to get that quarter or teat measurement in a conventional milking cluster. And that's really what the idea was. And that's basically the sensor we've developed.
And the robots, they're not being used widely, I understand, in New Zealand, right?
No, it could even be less than 10 in all of New Zealand, like 10 milking robots. It's almost nothing. A lot of good adoption in Western Europe, Netherlands, a bit of Germany. There tends to be a fair bit of government subsidies behind them, which just aren't an option here. And they just work for small herds, which we also don't have here. Yeah. So the robots are already doing it. And I just saw that opportunity to do it in a much simpler way here.
And what does the robot do exactly? Like the robot sure can detect that a teat has a change in saltiness. Like what happens after? Does it just tell you that's it?
It'll just push them to it'll draft them to a different area of the farm. And then it's still up to the farmer to manually check that cow. So that's the interesting thing about robots. It's almost continuous alerts you're getting because the cows are milking all day by themselves. And so it's almost like a 24/7 job of getting more and more alerts from these robots that you have to deal with. Whereas at least with our milking, we just do it in the morning and night and you see everything then. But so I had this idea, but I didn't immediately go into it. I had quite a list of ideas that I've kind of accumulated over the years that I wanted to explore at some point. But I tried to be really logical about it and think, I basically have no money. I have no real connections or networks. So if I just try to compete with other people on these more generic ideas, someone else is probably going to beat me with more resources. So I thought, what do I know more about? Or what am I more qualified to do than basically most people on earth? And that is my kind of unique combination of medical device, diagnostic development, and dairy farming. And so I thought, okay, this is what I can do that most other people can't. I also have a farm, 100 meters away with a herd of cows that I can start testing on, which is also something most people don't have.
Yeah, so quite a good fit, I guess, founder market fit for that problem. So once you've done the research and you kind of said, okay, I want to go for it, like what were the next steps? How do you go from like a concept, I guess, on paper to a real thing?
Yeah, so initially it was just a lot of, so we wanted to do technical and market validation was the idea for those first few months. So just taught myself a bit of electronics and I made these prototypes. I did all this testing in the shower with all this mastitis milk that I collected from the farm, which didn't win me many brownie points at home, all this horrible rotten milk. But I eventually started to get a feel of how to make these conductivity sensors, which are actually really simple. It's just 2 stainless steel probes, but then it's quite difficult to make that sensor work. In that part of the milking system, there's basically a pulse of milk every second, followed by a lot of air and turbulence. So it's very difficult to get any kind of good signal out of that. There's just so much going on. And so I started working on the geometry of how the sensor would actually capture this milk without holding it, because it all needs to drain and clean all the time. So you can't have a pocket of milk sitting somewhere that you measure. So everything needed to be, it needed to give a good signal, but comply with all cleaning standards and also be fully usable by the farmer. It couldn't be the size of a water bottle or something, because you're working with a very limited space and the whole thing has to be retrofittable. So initially it was just some really basic prototypes and testing it on Dad's farm, and we saw it actually work, which was quite surprising the first time. But we tested 10 cows, I remember the day, 9 without mastitis and 1 with it, and we got it all right. And that was a very basic system, all like hand soldered together in a little lunchbox. And I used to sit in the cowshed under a raincoat with my laptop plugged directly into it to see the data coming out. And so the cows would be cracking all over me, and I'll be there on my laptop.
Why were you in a raincoat?
Just because the cows were urinating and everything on top of me. But I had my laptop plugged into the sensor that was connected to the cow, so I had to be protected. But we had no data logging. There was no Bluetooth connection.
So you're saying like the cow, while it's getting milked, it's urinating as well?
Yeah. They just go for it the whole time. more than Europe. Yeah.
Wow. So
Yeah, you know how you say like founders have to eat a lot of shit in the beginning.
Yeah. I
Seems
think
to
I
be
actually
awfully
did. I
close.
probably did eat quite a bit, literally.
you were literally getting shit on
Yeah.
by cows.
That's crazy.
For the first 3 or 4 months. Yeah.
Wow. Do you
but
have
it
any
actually
pictures?
worked.
Do you have any pictures of this?
Oh, I've got pictures of me in the. I don't think I do because my dad wasn't too handy. He's not too handy with a phone. So I don't think he'd got to the stage of being able to take pictures on his mobile yet. And I was there quite busy. So, but yeah, I do have some photos of those early days.
Well-
Yeah, I thought if I could make this roughly work with this basic electronics and this first version, what could we do with a bit of funding?
So what happened next? So you got the sensor, you got it to work.
Yeah. So that was the technical side of it. I was like, okay, there's some legs on this. And then met a guy at a startup event, and I was telling him what we're doing, and I said we're going to go to Fieldays next year. And Fieldays is the main agricultural farming trade show in New Zealand. And he said, well, why don't you go this year? What's the point of waiting till next year to find out if this is a good idea? And I said, well, I've got no commercial product. I don't have a product that works. I can't go. It's only in 2 weeks. I've got nothing to sell. He said, just go and see what happens. And so we went for 4 days. I just got a piece of pipe from Bunnings and put a light in it. Like none of it was real, but it showed what the concept would be. And yeah, we just shared a tent with a hoof trimming company, and we just harassed every single person that came past with a little sign written in felt saying, dairy farmer feedback wanted. And yeah, we got about 110, 120 farmers sign up to say, like, if you actually make this, we'll buy it. Like, this is great. So yeah, Alex.
And what was it? What was it that you were
great
telling
idea.
them that you had? What was it that made them interested?
We just said, you don't have to, it's called stripping the cows. That's where you manually check them. We said, and everyone hates it. It's one of the worst jobs on farm. And it comes out of nowhere because you think you're okay. Then you get this big spike in mastitis. You got to find someone to come and do it or waste half your morning doing it. And so we just told them, look, you're going to find your mastitis earlier before it becomes more severe. You never have to manually check it again. And it only costs this much, which is about 5 times cheaper than anything else out there that does the same job.
What are the
And
other
so
things out there that do the same job? Like what other things could a farmer use?
Yeah. So in terms of automated systems, there's not a whole lot. There is one which is accurate, where it does that cell counting measure on the farm that I talked about earlier. And so, that's the same kind of science. It's another proxy for mastitis, and it does work, but it does cost, a few $1,000s per set of cups. It require a team of technicians and electricians to come in and install that. And there's a fair bit of maintenance, and there's a reagent. And so all of these things are reasons for farmers not to buy it, just making adoption harder and harder. So we were very clear from the start, we need to make this affordable, easy to use, easy to install, a really fast result, and a really accurate result. And only if we achieve all those things, a farmer's going to take this up.
Interesting. Can you show us what the product?
We did that trade show, and then we had that market validation, we had the technical validation, and that's when we started looking to raise some money.
Can you show us what the product looks like?
I could share it. I'm actually,
Yeah, you can share. You can share a picture. Yeah.
Yeah.
Or maybe a video. Yeah. Walk us through it. It's sort of like what I found really interesting when we first met was like how surprisingly simple it was, and how
it is simple, and we get that a lot. And I've even asked some of these large players, like, why haven't you done this?
What do they say? What do they say?
They're just so focused on, say, maybe it's the engineering culture within them, but they're so focused on making the most complicated thing that makes the most data, the most accurate, fully integrated, like just peak engineering. But farmers can't actually afford that or maintain that. And so it was all about how do we make something which is bulletproof, no moving parts. We can just send it to farmers and they can do it themselves. They're not scared of software upgrade costs. They're not scared of technician costs when things break down. They're not scared of reagent costs. Yeah, but other players just seem to be interested in making the ultimate system, the ultimate integrated connected system, which is not New Zealand farming and not farming in most places in the world. I'll share this here. Sorry, this is from a pitch, but yeah. So this is our solution to this mastitis screening problem. It's called QuadSense, and it's made up of 2 main parts. So these are the sensors we developed, which we have a patent on, a granted patent on. And these are unique because they allow that milk to flow through. It doesn't increase the length of the milking cup. Doesn't trap any milk, so everything's fully cleanable. But it is able to take these conductivity measurements continuously, even though it's a pulsed flow of milk.
And where are the sensors? Are the sensors in the top and bottom of that tube, or?
Yeah, so here's a picture of some milking cups. And so normally this is just one rubber tube coming from here So this is that collection bowl I talked about earlier. So these are the 4 milking cups, and they all come to this central point. And so this short milk tube is really the only place, the only opportunity we have to take that quarter measurement or that teat measurement. And so the sensors had to go in here. But yeah, as I said, there's a lot of fluidic issues with putting sensors inside this pulse flow. So it's really easy to install. You just cut this rubber tube and you insert each of these sensors, and the farmers can do that themselves. And these continuously measure that conductivity data. And then that all runs up to this control unit, which you can see here. So a really simple self-installable device, battery powered, but a 3-year battery life before they need swapped out. And it's just a simple battery pack in the top. And again, that's removing any need for electricians. And so this is really streamlined, low key. It's not in the way or in the face of the farmers, but it's always there and always monitoring. And they very simply get a red light after 30 seconds if the cow has mastitis. And so everything we did was thinking, how simple can we make this? Like it would have been more interesting maybe from an engineering perspective to have a screen and then have a central dashboard somewhere and stream all the data there and take it to the cloud and do everything and all the bells and whistles.
Put it on the blockchain.
Yeah, exactly. Yeah. And put an AI voice inside of it to talk to the farmers. But actually talking to farmers, what do they actually need? It's a messy place to work. It's tough. The cows are kicking you and everything. It's very time intensive. And so they just need the quickest, simplest alert that they can get to react to it.
And so you just literally have a resistance sensor and a light. That's all it is.
Yep. Powered by some AA batteries.
It's like the simplest circuit you could build. Wow.
And the start was to be like, at least twice as cheap, but at least twice as accurate, and at least twice as, it's got to be, it can't just be 10% better. It's got to be at least 100% better.
So what is the, like, how are the sensors work? I'm curious how you solved that, because you mentioned like the fluidics going through it. Like there's some kind of hard things there.
Yeah.
How did you design the sensors?
Now there's 2 parts to it. The first
if you want to show an image, we can also, that's easier.
Yeah, probably it's not too complicated, so I can just talk it through, but it's really important to capture the first milk that comes through. And so we have some kind of directionality, some fins that push the milk towards the sensors and towards the electrodes in the right way. So you always capture the first part of the milk. And then the other part of it is really just restricting a small part of the milk flow, so that if there's a pulse coming through every second, you want the milk to be kind of restricted and slowed down in this small segment so that it stays there for at least 1 second, but really no longer until the next pulse of milk comes. And so it's fairly simple, but so you've got this kind of measurement area where the milk is being slowed down, but it's always draining, it's always moving, and it's always been clean with the cleaning systems later on. But it slows it down enough that there's actually a continuous pocket of milk in that area, because it just lasts there for a second, but by that time the next pulse has come. And so rather than this really turbulent, fast flow coming through with a pocket of air in between it, we actually get a continuous measurement across our electrodes.
How do you do that? How do you trap the milk in there temporarily?
It's really just a restriction at the bottom of that chamber. So the milk gets in there, but it can't actually flow through fast enough to drain immediately. It takes about a second to drain out of that measurement area.
I see. So you basically narrowed the base or something.
Yeah, basically narrow down part of it. So the milk takes longer to drain out of there. So instead of flowing through in 0.1 of a second, it takes a second to drain through.
Does it have any implications for the milking, like slowing down and the milk getting kind of like backlogged?
There was a concern at the start, but we've done all the vacuum and flow rate testings, and it has no effect. It's a fairly small part of the milk. Most of the milk is just flowing straight through still.
So what was simple, it like?
But definitely on purpose.
So talk us a little bit through like the next steps then. So you had all the validation, technical and commercial, and you said, okay, now it's time to build this, and you need some capital, right?
Yeah. I was fairly inexperienced at this, but I started going to the local angel events and local startup networking events, and I thought angels were the normal way to go initially, but I had a really good chat with a guy called Robert McPhail from Pacific Channel, and he said, look, we're interested in the early stage. There's no need to go to an angels first. You can work with us straight away if you like. And so that's what we did. So we got a small portion of money from them initially in 2021. And then we used that to actually get some proper electrical design done and made some much better prototypes and did some much better trials. And then continued that market validation. Now it wasn't good enough to just get letters of interest. They set us the target of, okay, go out and actually get deposits for sales of this thing that doesn't even exist to show that market demand. And that's what we did. So we had 100 units pre-sold 2 years before we even released the thing. And people actually would have given us money to pay for something that didn't exist. Was really good market validation. And they agreed. So they gave us some more money.
I think we also gave you money.
Yeah. So that one was in 22. But yeah, so get into that. So by the end of 23, we had done all the technical validation we wanted to do. And that's when we wanted to start the commercialization, the real commercialization. So setting up the supply chain, the operations, the sales systems, and sales themselves. And that's when we did our first big round. And that was with Pacific Channel, ZVC, Enterprise Angels, and 102 Angel Group as well. So that was our first more substantial round. And that set us up to launch the product. And so that's exactly what we did. So from end of 23, through the first 6 months of 24, we got on more trial farms, got real testimonials, set up that full supply chain, CRMs, who are our customer segments, what's our sales pitch, how are we going to do this? And then, launched at Fieldays in June 2024.
Great.
That was
it's been a wild ride in the year since then.
You guys have I think, was it some really large number of farms are now using the product, right?
Yeah, so we have 145 farms now with the product. So that's about 2% of the market that we've captured from no product to a year after launch. And actually in our local areas where we started, we're getting close to 5% market penetration. So in the ag industry, that's considered fairly quick. It's a physical product that needs to be manufactured, made, seed, delivered. They actually have to install it themselves and use it. So it's not as quick as SaaS potentially, but we really think we've cracked up something here.
Yeah. There's New Zealand has this whole kind of a number 8 wire mentality.
Mm-hmm.
Kind of it's known for. The number 8 wire was this kind of all-purpose wire that you could fix anything with. Because I guess New Zealand, what was the story? New Zealand was so far from everything that farmers would just fix everything with the wire.
Yeah, my dad's a really good example of that. Actually, he's I think it's a positive and negative mentality, and I've learned to get out of it the further down this journey I've got. But it's really about why spend any money when I can make this work with some kind of quick fix, and this will do. And that's what I did do for the first 2 years. It was how little money can I spend? How much of this can I do myself with things that I can just buy from the shop and whack it together? And even if it takes me 3 times as long, I would just do it this way and save some money. And I think I did have to be quite innovative and resourceful in that time and use just some basic components that I had access to. But if I did it again, I would just be more confident, get more money from the start, get experts involved and some real professionals, and probably do what we did in 2 years and 6 months. And so I'm trying to get out of that number 8 mentality, really. It's great for the innovation, but you actually have to start spending money and get some real progress.
Well, but I think, I guess I kind of see it as more of you can do something with very little. And I think your product is actually a good example of that, in that it's a very simple product, right? And it's like you said, it costs an order of magnitude less than existing solutions. It's an order of magnitude more precise and accurate than existing solutions. It's it was sort of a very, very super simple thing to make, right? It's always if somebody tells you about it, it's oh yeah, of course that's how you do it. But getting there is I think it takes constraints.
Yeah, and I think we reflect our farmers as well. Farmers are quite practical, robust, and just want to get the job done. There's no real frills involved. And we try to kind of bring those same principles or values into our business and into our product. And I think that it resonates with our customers because we're the same as them. We've not added anything extra to this that doesn't need to be there. There's no moving parts. There's nothing to break. And it's just going to do the job. And so your farmers seem to just resonate with that immediately and trust us in a way. We're not going over the top. We're just here to do the job.
Yeah.
Do you plan to add analytics and an app and just other ways to track the data?
Yeah, so we have an app at the moment which allows them to adjust the sensitivity of the alerts, which is really important because all farms are different, and they can manually add alerts into the app and it can do all the analytics for them. So that is there. But what we're missing is almost no farms in New Zealand have the technology to say which cow is in which position. And so for almost all farms in New Zealand, we can't track automatically the health of the cows or the mastitis of the cows or the production of the cows. And so that's a really big next step for us, is to either partner or work on something ourselves, which allows us to do that and link in and give that longitudinal data for these cows from our sensors, which are really the first sensors of this type to deliver this kind of resolution of data. So it'll be amazing what we can do once we make it more of a platform that's linked into the cow ID. But it's been great to be able to have this kind of MVP product, which has made us money. We're profitable and we're a hardware business, early stage. It's quite a proud achievement for us. It's not just VC money that's keeping us going. This is actually a real business, and it's a great first product that we've validated technically, and now we can really push it and push it to its limits of what we can do with these sensors.
Yeah. And maybe zooming out a little bit, New Zealand seems to have a little bit of a moment in agriculture technology. There's obviously Halter, who just raised a big round and is now a unicorn. Do you think it's like the best place in the world to build agriculture technology, and what makes it?
I think New Zealand's quite good in general in terms of starting businesses. I started Bovonic and it took half an hour, and then I was a business. I feel like there's more of a mentality of like maybe break some rules, or you don't need perfect processes or perfect documentation. Just go and do it and see what happens. I think that's probably part of New Zealand culture a little bit. We don't have a huge respect for hierarchy or rules. So I think that's really freeing. So you can just go for it and do it, and people respect you for that and like you for that. And then I think it's exactly my story, and actually Craig from Halter, not that I can compare our valuations, but he was in engineering at Auckland at the same year as me. We're both from farms in the Waikato. And it's probably that a big portion of New Zealand students come from those farming backgrounds, and then they get into all these new engineering, science, technology fields, and then they see that gap, which you wouldn't see if you'd, had grown up in the city potentially, and you wouldn't see if you stayed on the farm. And so, it seems to be this good combination. We've got this big portion of the population who has this farming knowledge, but they're all going to university and getting these engineering or science degrees and putting it together.
Yeah. And is there also an element of, like, as you mentioned earlier, because there's no subsidies, farmers just always had to be a bit more inventive, a bit more just kind of making things work?
Yeah, people have said that New Zealand farmers aren't great at adopting technology, but they just have to be a lot more ruthless with that return on investment. There's been a lot of high-tech, high-priced product from Europe being tried to be pushed here in New Zealand, and it's just not worked, because it works if you've got subsidies, but it doesn't work in our systems. But if you look at like Halter and the other collar systems, they had almost 0% adoption in 2018, and now it's almost 35% adoption, which is pretty rapid technology uptake for a group that people say are backwards on technology.
Yeah. So you would say that, like, if you can sell to the New Zealand farming community, that's like a really good validation that you can sell it anywhere in the world.
Yeah, because they've got no free money coming from anywhere. It's got to be a business decision. For us, mastitis is actually pretty good in New Zealand. We don't have high rates of mastitis because the cows are living in clean, grassy fields. In Europe and America, they're in barns all together, always sitting on the same spot, always touching each other. So mastitis is actually a bigger problem overseas. So we think it's a good validation market that we've been able to sell here.
But because it's a bigger problem, are there more solutions overseas that maybe those farmers can afford, more expensive ones?
Yeah, more of them do tend to have milk meters and more of that cow ID. Measuring each quarter will always be better. So even though they might be more advanced, we can make a more advanced version of QuadSense for them that is fully integrated, but delivers this new type of data to them. The real goal is taking this quarter measurement data that we can generate, which has previously only been for the robots, and we can bring it to everyone.
Yeah.
How do you grow from here? So, like, you've gotten some interesting adoption in New Zealand. Kind of what's next? Like, from what I understood talking to you and learning about the business, is like different countries have different things that they're good at. Different, again, like you said, subsidies. Like for New Zealand, it seems like all cows are by default free range, whereas like I think in most other places in the world, only some are free range. There's like a bunch of these like structural differences between the ag markets across different countries that seem like quite a lot different within an industry versus like some other industry, like finance maybe or something. I don't know.
Yeah, for sure.
Because like almost like completely different like industries from country to country.
Yeah, I think we've picked something which is more universal than some other parts of farming. So a lot of these collar systems or some of the apps that come out of New Zealand are very pasture focused. So it helps farmers who are putting their cows on paddocks and feeding them grass. And so those products will be limited to countries where you do that. So most of Europe doesn't do that. The good thing for us is milk and cows, except for the robots, are the same everywhere, whether it be developing dairy industries like in Vietnam and China, or very advanced ones in Western Europe who aren't robots. Our sensors will fit into all of them. So yeah, our main first priority for growth is just prove that this isn't just another New Zealand product, but it's a global product. And so that's what we're going to be launching at the end of this year. We'll be in the UK and Ireland, followed quickly by a couple of markets in Western Europe, and then hopefully by the end of next year into the US. So that's priority number one. We know the product works, and we know it's going to be compatible in these other markets. And then the next step is saying, what else can we get out of these sensors? So at the moment, it's a mastitis screening device, but we should be able to do hygiene validation, which is really important. We should be able to do milk production of each quarter, which is again something that is only currently accessible on robotic systems, which cost hundreds of thousands of dollars per set. So yeah, QuadSense will move from just mastitis detection to a platform of collecting basically all the interesting information from a cow, so farmers can link that in, optimize their whole systems, and yeah, just be better farmers.
Interesting. Well, can you tell us more about the market? So like, I didn't know much about AgTech, and I didn't realize it was like even a market until I got to New Zealand, and then I learned about Halter. And Halter is this like, basically, I don't know, it's like a taser for cows, like on their neck, like tases them to like moves.
They wouldn't say that, but
okay.
Yeah, you could see it like that.
What I mean, that's how I understood it initially. What is it? And maybe you can talk to us more about like just AgTech as an industry in general. Like, do you see different parts of it growing differently? Like, why did this whole collar thing take off? Like,
yeah, I think the background technology just came along far enough. So 20 years ago, most farms had no connectivity in New Zealand or any kind of computer systems. That's come a long way. So you can actually get internet on farms, and farmers are very interested in optimizing their processes, and you need data to do that and to take a lot of those manual jobs out. And so they were always willing to do it. And I think all these other technologies have just caught up or finally penetrated the rural places so that they can be enabled now. That's certainly the case for the collars. Collars on all cows is totally standard in Europe where they live in barns. That's been totally normal because it's quite a small space and they've got that connectivity. I honestly think it's just that these rural places getting internet access enabled all of this, what had been fairly standard overseas, to come here to New Zealand. And off the back of that, I think there's been a huge amount of data, and then we can actually process data now very quickly and much more intelligently and give people an app so they can view it all. So I think it's just all these other enabling technologies has finally reached this market, which is often the last to see some of this infrastructure changes. I'd say that's a big part of it. I don't think it's that different than in other industries. And certainly in Europe, the technology is incredible. And there's a lot of billion-dollar dairy technology companies,
really?
Laval and Yeah. And these milking robots, automation is very hard, especially with a living animal who you can't fully control. And, people are finding automation to be much more difficult than maybe we thought it was. I bet people thought we were going to be further along in automation by this stage than we are. And so, robots in the dairy industry has been around since the 80s and 90s. And so there's been a lot of advanced technology for a long time. It's just, it's really just how easy is it to adopt, and different markets just have different buying power.
I see. So you're saying Halter is more of just a New Zealand phenomenon. It's not a global. Is that right?
They would definitely disagree, I'm sure. But yes, from a dairy perspective, I believe so. But they get into the beef side of things, which is largely pasture-based. So they've got a very big potential market in the US and maybe South America for that.
I see.
But it is pasture-focused. So for your farm in Germany, it's probably not a useful tool.
And for you and your products, where do you see the UK and Western Europe kind of the next biggest markets?
The UK, so Ireland and the UK have either copied or adopted a lot of New Zealand technology, and the systems are very similar to how we do it here. And there's obviously that easy culture, the very low cultural barrier. So for us, the UK and Ireland, we're going to first simply because it's an easy first market. I'm sure we're going to learn a lot. We're going to learn a lot about exporting and setting up subsidiaries and all of this. So we just want to do that in a kind of the lowest risk, but still a high reward way we can. Western Europe will be interesting. They've got these subsidies. They're very focused on mastitis. The EU is bringing in new laws where you can't just give antibiotics to any cow willy-nilly. You need to actually have some kind of diagnosis against it. And so we can be a big help there. But really the US is the big prize. They're huge farms, huge number of cows, each one of them, huge production, but it's a big market to get into. They farm very differently than most other places in the world. And so before we go there and burn ourselves or burn through all of our capital, we need to do a bit more research and understand that market first.
Yeah. And you're kind of sitting on
trial for that.
You're kind of sitting on packed bags at the moment, right? Where are you
Yeah.
off to?
Yeah. So we've made the decision that, starting in a new market is difficult to just hire someone in that market and not be able to ingrain them in the team culture or the team passion. And so, yeah, we've decided that myself as founder should go and start those markets myself. I've got a fairly good idea, as you'd hope, of the product, the operations, and the sales side of things. The founder story is really powerful, and I've obviously got that motivation to do what it takes to start those markets. And we've got a really incredible team here in New Zealand who's going to keep the New Zealand business going. So yeah, just waiting for the visa decision, and I'll be
And
packing
you're
my
going
bags.
to the UK. Yeah.
Going over to the UK to base ourselves there and start to set up these first overseas markets. Yeah, if the British government will let me in, because they seem determined to make it as difficult as possible.
Liam, we had Irina on the podcast a few months ago, and she's the founder of Daisy Lab. I'm sure you're familiar
Yes, I listened
with
to
that
that one.
And she's trying to create plant-based milk, and she she doesn't like the idea of milking cows or kind of using animals for food in general. And there's quite a lot of kind of research and work in that direction. How do you think about that more, like where we're going as a society? Like, do you think over the next 5-10 years we'll continue to milk cows, or you think like at some point the technology will get really, really good? And I mean, there's other kind of trends where like people are now drinking plant milks and like, right? Like there's these other like alternative milk
I'd call
things.
it plant juices, not milks,
Yeah.
but yeah, they are. I'm a big, obviously, believer in technology and science. So I think there will be a point where they can make something which is just as healthy and contains everything that milk contains. But I think milk is a lot more than just replicating a few proteins. It is one of the most nutritious foods you can get, especially for which is not as much of a priority for us in the first world, if we still call it that. But I think a lot of developed countries understand the importance of good nutrition, and that's why a lot of the demand comes from those countries, and I think it will continue to. I think there could be a point where, plant-based or artificial milk is a full replica of milk, and I'd be happy to drink it. But I don't think it's going to wipe out conventional milk. There's going to be a huge market for many decades, I think, for people that want it to come from another mammal who's made that milk to nurture its young, and that seems like a sensible thing to drink. So I think it will happen, but and maybe I'll learn more as I go overseas. But from my perspective, the New Zealand way of farming is, and maybe I'm biased, but it's not a bad life for the cows. I don't know, they're cruising in the grass and eating all day, and they get milk twice a day and get a bit more feed. And there's some tougher aspects of it, but yeah, no, I think it's going to take quite a few decades for that cultural shift. And I think we saw that a little bit with these artificial meats as well. There's a fair way to go before people fully get behind them. Yeah, but I'm not opposed to it. I saw them come to Fieldays, an innovation tent there, which I thought was really admirable, because I'm sure they're going to get a fair few harsh comments from farmers saying you're trying to take away my job, and that is a difficult aspect of it. But I think all automation has to continue.
Well, there's another company called Miruku. Maybe you've heard of them.
Yeah.
And they actually try to, Amos, he also comes from a farming family, and he kind of tried to square that circle of like, you don't want to displace the farmer, but you also want to move towards a plant-based or some kind of like, artificially created milk substitute. And so what they do is they try to grow all the components of milk, the proteins and the fats, inside of like saffron seeds. And then you sort of just use regular extraction techniques from the seeds. You basically are extracting milk from the seed. And so you still keep the farmer in the loop. He still has to grow the saffron. So the farmer basically, instead of milking cows and milking plants, and they sort of try to like do it that way.
Yeah. Yeah, no, that's a fair enough idea. I don't know. I'm fairly conflicted because that's my family background, and it would be sad to see it all disappear. And I don't think it will for many decades. And I think there's always going to be a fair market for real cow's milk. But at the same time, 200 years ago, 90% of people were farmers, and the world's still going, even though it's only 5% or 1% now.
Do you drink milk every day?
I do. Yeah.
What's your favorite?
I don't touch the oat juice or the soy juice. I can't be a dairy tech founder and be drinking.
Fair enough.
Do you drink it like fresh from what your own cows? You get milk and you just drink it, or do you buy it from the store?
I have, but not on the regular. No, I have it with my wheat bix in the morning, and yeah, I'll drink a glass of milk.
What's your favorite?
They all come from the same cow. I don't.
Do they?
Don't worry about that at all. Yeah, yeah, I know there's these super high end ones that come from Jersey cows or this, but most of the milk it all goes
Well,
to
I mean,
one
I
three
don't know. Have you
players.
had this like Lewis Road Creamery milk?
Yeah, yeah, it is very nice. I think they probably take a little bit less out of it compared to your standard. I think oh, I haven't had my exit yet, so I have to wait to pay for that.
But it's like, but I like, it's just like, it's a very, I don't know what they do, but the milk actually naturally tastes sweet. Like, I don't know
Yeah, I
why.
think it's just like, so Jersey cows produce higher fat and protein milk, or definitely higher fat. And I think they might just leave more of it in there rather than basically leave more of the cream in the milk.
Oh, wait, so when you milk a cow, the milk that comes out has more fat usually?
Yeah. So you can separate it, and some of it gets turned into butter and whatever, and then a certain portion of it becomes milk that you sell in the shop. If you milk a cow, if you milk your own cow, you get a big layer of cream at the top, which is like delicious, but it's just cream. You don't buy that in a bottle. And it is very good. I know they call it oat milk and all of this, but it's not actually the same thing in terms of its nutritional content.
It's got the same color though, right? But yeah, other than that,
It's got the same color, and it works in a coffee.
Yeah. Cool. No, that's awesome. Yeah, we really appreciate you taking the time. And yeah, we're big fans of Bovonic, as you know, and we're super excited
Yeah,
about
thank you very
your
much.
upcoming new market, UK. Yeah, we hope we see you soon for a glass of milk and catch up then.
Absolutely, yeah.
there was one unique thing I didn't realize about New Zealand, which is like New Zealand is actually the world's largest dairy exporter, right?
Yes. Yeah.
Even though it's not the biggest.
Which isn't to say we make the most milk.
Right. That was the sort of the interesting thing is like it's not the biggest dairy producer, which I think is like either China or the US, but
Yeah.
vast
We're
majority
about
of
number 12, I think. Yeah, we're the 12th highest dairy producer, but I think we export 95 or 96% of everything we make.
Mhm.
So we definitely punch above our weight in that regard. Yeah. And it's also, well, from what I've seen, the most green and lowest carbon emission milk in the world, the way we do it here, because we don't have to build big concrete buildings. We don't have to heat them all winter. It's all very natural, as much as farming can be.
Interesting.
Yeah. So I know we're trying to cut down cow numbers, but if anything, based on those numbers, we should be increasing cow numbers here and decreasing them elsewhere if you actually want to reduce emissions of the global dairy industry.
Right. And that export of dairy is actually dehydrated milk powder, right? So like they take the liquid out.
Predominantly, yeah, for China. Yeah. Which has always been an interesting part of our industry. Like everyone keeps saying we should be focused on more high value items, but we just never seem to work it out. There's some good examples like Tartua, which is our main like whippy cream that you find in the supermarket. They do an amazing job as a small factory producing this specialty product and getting a lot more for it than milk powder. But yeah, no, we're certainly doing okay with the milk powder. Farmers are happy. Everyone's making a bit of money. It's an interesting question. What else should we be doing with this milk that we produce?
But it's also like a very, because I don't think, like dairy farming was introduced when British like settlers came to New Zealand, right? And it was like, I don't know if it was like, it almost feel like, yeah, New Zealand is a pretty well, like you're saying temperature wise, it's also like quite sparsely populated. There's like a lot of room for cows to like roam and like feel happy. Like it's pretty, yeah.
Our climate's just incredible. It's never too hot and never too cold. The cows can just stand outside all year eating grass. It's very, very lucky.
Right. But how come the sheep thing, like how come there are more sheep? Because you always like hear about this like statistic about there's more sheep than people, but it's actually like dairy is the biggest exporter. Like
Yeah, well, it's an interesting point like you brought up earlier around synthetic milk. Obviously synthetic fibers totally kicked off and dominate now, and you can't make any money off wool. And so I think there is a big difference between something you wear and something you eat or drink. And I think there's a lot more, I don't know if it's called cultural, those human barriers to trusting something to put inside, to eat or drink.
Interesting.
But yeah, certainly for the sheep, the synthetics totally took over. And it'll be interesting to see if there's a point one day that happens with food as well.
Oh, I didn't realize that. So interesting.
The milk price has been really good since, the early 2000s through to 2015. It was just made no sense to have as many sheep, and there was so much money in dairy, so everyone just switched over.
Right. So are there now more cows than people, or not yet?
It's in the 4 millions. So
Really?
yes,
Oh,
just slightly less than people.
So very
About
close.
1 cow per person.
Oh wow.
And there's still, I think there's still more sheep in New Zealand than people.
yeah, no, I'm sure. Liam, thank you so much for spending this time with us. And yeah, we wish you all the best for your upcoming stay in the UK.
Yeah, no, thank you for your time. Really appreciate it.
Cool.
Yeah,
Thank
awesome,
you.
man.
Cheers.
Great work.
See you later. Thank you.
Thank you for tuning in to TechMates. If you enjoyed this episode, be sure to subscribe, leave a review, and share it with friends. We'll be back soon with more stories of Kiwi and Aussie founders reshaping the future and disrupting down under. Until next time, keep dreaming big and daring to disrupt.